Well, another question on demand. 2022 October November series paper 1-3 question number 28. Again it's on double Young's double slit interference experiment, but slightly with a different idea. In fact it is using they are using in this question a dichromatic light source. Means it consists of a white light coming from red and violet. Usually in the interference experiment we use a monochromatic light source. Means over here we have a single wavelength source, but right now we have a multi wavelength source, which is by red and the violet light. And you know that red has a greater wavelength, r lambda is greatest, and violet lambda is shortest, violet light. The wavelength of r is approximately twice the wavelength of v, so means r is bigger in terms of wavelength. A parallel vertical double slit is placed nearby. A white screen is placed so that the fringes are formed in it. Which graph best represent the interference fringes formed on the screen? Now look at the four options A, B, C, D. First of all, you should remember one thing, that on a white screen, imagine we are viewing this point, and the graph plotted, all these four options are plotted for this location in the center of the circle. Okay, and this point we always have a brightest light because it is a constructive interference at the center of the screen. So for the constructive interference we should have a maximum intensity. Now if you look at the graph A, option A, we are getting a minimum intensity, so option A is incorrect physics. Although in option B we are getting intensity, but only for the violet light, not for the red light. And according to interference situation, or in physics of interference, all the waves collectively combine to make a constructive interference at this location. Remember that. So here only violet light is mentioned. So again this option is incorrect. So it could be C, it could be D. Now you have to decide between among C and D, because violet and red both are making a collective interference, a collective intensity value. It means it's the brightest point. Again it is the brightest point. Now you have to look very carefully. Lambda is equals to AX over D, where A is the separation between the two slits, D is the distance between the double slit and the screen. This is A, which is constant, and which is constant. It means the fringe separation over here, the fringe separation is depending on lambda. So the light which has greatest lambda should have a greatest separation, and here red light has a greatest separation, greatest lambda, so it must have a greatest separation. So if I look at this option here, this is the brightest point, and at the far end we are getting red. Over here we have a brightest point, but at the far end we are getting violet. Violet shouldn't be come at this location because it has a shorter wavelength. So the right option is C because of this theory. So that is the best possible graph according to the question we can opt for, the option we can opt for. All right, thank you very much.